Hello everyone. Good morning, good evening, good afternoon, depending on your location, as we have attendees from all over the world. Welcome to another session of the DataHour series. We are thrilled to be with you here this evening for a session full of action-packed learning. I, Shishir, part of the data analytics team at Analytics Vidhya, will be the moderator of this session. For this, who have joined us for the first time, a brief introduction about the DataHour sessions conducted by Analytics Vidhya. DataHour is a series of sessions conducted by Analytics Vidya, which are led by top industries leader. It is a fun way to understand the concepts of data science from the leading player in the data science domain. We are hopeful that these sessions are going to be a great source of enrichment and value adding for our community members. Now, on to our today's session, which is about learning path to master data engineering. Now, on to our presenter. In this session of DataHour, we have with us Shashank Mishra. Now, Shashank is an experienced data engineer with a demonstrated history of working in service and product companies such as Amazon, Paytm, McKinsey. He has solved various data mysteries for different domains like aviation, pharmaceutical, fintech, telecom, employee service. He also has a good experience of designing scalable and optimized data pipelines to handle petabytes of data with, with batch and real-time frequency. Currently, Shashank is an active contributor to the data science and data engineering community through his incredible podcast and YouTube channel. Shashank, the virtual stage is all yours.
Hey, thank you. Thank you so much, team. First of all, having me here and giving me this opportunity to interact with the audience across the globe and talking about the data engineering. And I'm again really excited for this session. So hi everyone, Shashank this side. And as the team said, I'm actually working in the data engineering domain since last 5 years, work for companies, Amazon, McKinsey, Paytm, and currently working at Expedia as a data engineer 3 level. So before starting the session, I know it is more about the data engineering. I would be really interested to know how many folks actually know about the data engineering, because why I'm asking this question, right? In the under the umbrella of big data, right, there is a lots of noise. Mostly people are just running behind data science, ML, AI, and probably they are a bit unaware about what data engineer do, what data analyst does, what BI engineering is, everything, right? So you can even say like yes or no if you completely know about the roles and responsibilities and everything about the data engineering. I would be really happy to see those answers. Okay, so far more no's here. Okay. Okay. All right. Okay, cool. So seems like a very mixed balance, but more inclined toward the no. I saw it's a 65% no and 35%, 40% the yes. So cool. I think that gives me a clear idea how to proceed with the session. So first I will actually explain the data engineering part, right? Even I will explain my day-to-day activities, being a data engineer, what I'm supposed to do and what I have been doing in my day-to-day activities. All right. So, and I will explain it with the practical example, right? What in the hierarchy where we lie and what we are doing. So data engineering under the umbrella, we know there are lots of job profiles. Data engineering is there, data scientists are there, machine learning engineers are there, analyst is there, BI engineers are there, right? So let's talk in terms of the use cases. Okay, use cases as in take an example of Amazon e-commerce platform. We know the platform which is being used by the millions of folks across the globe. Even every second you should expect millions of transactions happening there, right? And nowadays what we can say, there is a very you can say there is a very sweet phrase which is like data is the new oil of the industry. The way raw oil empowered the industrial economy, same way data is empowering the information economy, and every company is heavily dependent on data driven business decisions, right? And these data driven business decisions actually happen in the phases, right? So how it will happen on the Amazon e-commerce platform, let's say every second millions of transactions are getting captured, and the data volume you should expect like the terabytes for sure, right? So Amazon e-commerce is consuming that data, whatever you are doing, right? Whatever you are doing there, you can say uh, you purchase something, you click something, you saw some products, right? Every activity of yours is getting captured, right? And once that is captured there, so what will happen, right? They are actually storing it somewhere, storing it. It can be any transactional database, right? It is something like a distributed database as well, right? Or even a distributed file system, for an example, HDFS, okay, or S3 like AWS S3, or NoSQL database like MongoDB, Cassandra, HBase, okay. So these are the things there, okay. And now we as a data engineer actually work as a frontliner, right? Any company is working on the big data solutions, data engineers will be treated as the frontliner, because their actual task is to create those scalable and optimized data pipelines, okay. So data pipeline is not, this word seems very like simplistic, okay. Data pipeline, we just bring let's say make connection to some source and just like bring the data to some downstream system. Seems very simple, but it is actually not, right? And that's why data engineering is more about the engineering stuff, okay. Just a second, just a second. Let me turn on my video as well. I forgot. Just a second, guys. I'm starting back. All right. Can you guys see me? All right, cool. Yeah. So I was explaining that where I was. Okay, so now let's say we have captured the data, okay, and the ETL or even creating the pipeline seems very easy, right? Okay, bringing data from some source and putting it to some downstream system, but it is actually not like that, right? More complex thing, and actual software engineering stuff is also involved here, right? Because you need to design those scalable systems where your distributed computation engines will be involved, and you need to handle the load as well, the data load. You need to create the scalable pipelines in such a way, even let's say at any point of time there is a spike in the data volume, your pipeline is not getting breaked, or even your pipeline is not taking too much of time to process the data, because there will be some complex business rules or the transformation you will be applying on the fly, okay. So you need to take care of everything, and that's why here you need to design these pipeline by following the best of the best software engineering best practices as well, right? We use the like deployment tools, right? We use the load balancers, we interact with the APIs as well, we design our system in the microservice formats as well, right? So everything, right? These terms I'm telling you, right, this is more related to the software engineering plus the data engineering stuff. And data science related job profiles, machine learning, and the AI ML related, it is more about the maths part, the stats parts, complex algorithm, right? Their use cases are something these guys are actually working on the or they are trying to solve some complex problems. So the first part I was talking about, the data engineers, their role is to create those scalable pipelines so that data can be brought from some sources, right? It can be again transactional database, some API, some NoSQL database, something like that. And we need to bring it into the downstream system. And on the fly, we'll be doing some transformations, right? Applying the business rules. For example, let's say Amazon payments team reached out to the data engineering team that we have a use case. Last month, whatever Halloween sale happened, right? We need to analyze that data. Okay. But for that, obviously, we need that data into the system. And to bring that data into the system, data engineers are the first point of contact, right? They are the one who knows how to create such kind of scalable pipelines. So they did that. They made everything available for the downstream system, right? And now your data is transformed. It is available in the downstream system. And now here onwards, the role of data scientists, ML engineers, and data analysts will come into the picture, because they are not bothered about like from where this data is coming, right? Whether this data is coming continuously 24 into 7, whether we are missing or not something, right? They are not bothered about it. They're actually bothering about the accuracy of their model, whatever they are trying to build. Let's say they're trying to create a predictive model, right? Recommendation engine, anything. So they need the accurate data as well, so that they can create the accurate data models. Their accuracy is good. Okay. So these kind of things they are doing. And then the data analyst as well, they are the data representers. They, whatever transform data we have made available for the team, they will be analyzing it and creating those beautiful charts, graph, or the dashboards, and presenting it to the end consumer. And that can be anything, your external clients as well, your leadership as well, or even your internal teams who have requested that data to you, right? So that's how this entire flow works. And we are the first one who interact with that large scale amount of data and just do everything for the downstream system data scientists and all. So that was the overall picture, and that's how even I work. I've been working, and how our life cycle works. Our internal teams or external teams can reach out to us. We have this use case. Can you solve it for us? And then we create the pipelines. And this actually how this happens in the phases as well. Doing things on the development state first, and work on the sample data, checking everything is good or not. And once we get the sign off from the business units or the end users, then we move things from the dev phase to the production phase, and then taking care of it, everything like monitoring, and something is not getting breaked. So these things actually happen. And that's why now how I actually chosen, right? The interesting theory is that people think how to even figure out which profile is best fit for us, right? This is also a big question. You cannot even move into data engineering because I am saying that. You can not even pick the data science profile because you saw some banners, or you saw, or you listened your close friend or colleague who is into data science. He said that, hey, Shashank, data science is so amazing. It's rapidly booming and companies are hiring. You should also move into it, right? Because moving into something uh, always actually depends on your interest. And I personally think you should always prioritize your interest. And that's exactly happened to me. I started my career as a software engineer, like into the backend development, front end development. But within a 1 year, by myself, I explored the data domain. What are the best possible job opportunities there? I even explored data science. I even explored data analyst and even data engineering. And then I figured out, yes, data engineering is something which is according to my interest. I wanted to keep my touch with the programming. I wanted to keep my touch with the large scale system building, architecting the things, designing the things, right? Microservices thing, playing with the APIs, building that large scale pipeline. So everything, I found my interest in the data engineering, and that's how I started my career. And same thing I would recommend you as well, right? Today I will give you the crisp roadmap, right? Very crisp roadmap, sequential. If you want to become a data engineer, and you have, like, even let's say you are a Java developer, right? I will give you that kind of roadmap, which will include everything sequentially, and most important things required to become a good data engineer. And that will be helpful for you for sure. You will get a very clear idea how to start with the data engineer, what are the step-by-step things are required. Okay, so we'll move ahead with that. Next thing, I just want to even share that document. I will present my screen, and we'll talk about each and everything, and even explain why that kind of a skill set is required, whether it is a good to have, must to have. Okay, But even before that, I will take a pause for the 5 minutes. If you have any question to understand data engineering more, or you didn't find my answer that meaningful, or you want more clarification, like we can take your question for next 5 minutes, and then I'll share my screen. So team, how can I get the question where I need to look at?
Yes, you can find the question in the chat section also, and few people have also mentioned their question in the Q&A section.
Okay. So in the Q&A, I can see 2 questions from, one is from Pratik. Is Java important in data engineering? I'll come into that for sure. When I'll present that screen, I will mention the first thing is actually programming. So you'll get your answer there. Anonymous attendee, which skill and tools I should have? Okay, I will explain it in the roadmap. Average salary for data engineer in India, Muskan. So data engineers are getting paid really, really well, equivalent to the software engineers, or if you think the data scientists or software engineers are paid really well. So now data engineer, earlier like 5-6 years back, that gap was pretty big, but now it has completely equal or even crossing the bands as well. Like I can't share my salary, but I have since worked with Amazon as well and other companies. So I have always got that competent compensation equivalent to the engineers. So like whatever companies you are targeting, if you think that, let's say on an average, as an entry level fresher, somebody is getting 25 LPA to 30 LPA as a software engineer, so you will be also getting the same. Man, can Google certified data engineer certificate enough? No, just certification is not enough to move into the data engineering. Man, certification is, I would say, a good thing, because you will get the sequential things there to learn. Okay. And after that, like there are a lot of things to do in the data engineering to get the practical experience. I won't say that certification is enough. Vishal, how can I work if I'm not good at programming? How much time? So see, the good part is that, Vishal, if you think that you are not good at the programming, first you can even try to get a good hands-on programming, but still you think this is not working out for you. I would recommend you to move into the data analyst and the BI engineering profile, right? Those are also pretty good, and the amount of coding is not required there at all, right? The way we do it in the data science or the data engineering. Roadmap, yes, absolute. Vashanta, the roadmap I'm going to share, it is completely for everything, beginner or someone the mid experience level and trying to move into data engineering. It will help everyone. How do you explore the data field, since most of the cloud and hybrid tech requires subscription? What was? Yeah, so I was this is the good question, right? Whatever I did in the beginning, I didn't enroll myself for any subscription, let's say for cloud platform or anything. I always preferred things to set up on my system as well. Like first I started with the open source things, right? I didn't run behind the cloud or learning cloud from scratch just for data engineering or big data. I focus on the open source platforms first, like the frameworks which are open source and being used in the data engineering. I was using it in my local laptop, creating projects, hands-on projects by my own. And then the exposure related to the large volume of data, or the you can say the cloud part, I got it in the organizations itself, right? So that is the best part, and same way you can also move ahead. Sadat, can a data scientist be definited from data engineering knowledge? Yes, yes, definitely. So these are the branches, right? Data engineering, data science, data analyst in under the umbrella of big data. So anytime if you are in the data engineering field, you just need to work on your right skill sets for the data science. You can move there. And even if you're working as a data scientist, want to move into data engineering, you can do the vice versa. I'm a big data Hadoop from last 8 years and having total 15 years of experience in IT. What is the advice for me? So Ganpat, you can just excel your skills in direction of the data engineering, because the base or the fundamental you already know, the big data Hadoop related things. It is more about getting the right skill set for data engineering, and you can easily move there. How long does it take to get the first job starting from scratch? So job hunting is definitely a time taking process in itself, but it can be simplified, or it will be helpful if you are having the right skill set, you have worked on really good projects, and you have mentioned it in your resume. So obviously you will get noticed by the recruiters. Make sure you are active on the LinkedIn and interacting with the audience and few people who are working in different companies, taking help from there, just for the referral and other things, right? Definitely that time can be minimized. All right, so cool. I think lots of questions more related to the beginner roadmap and all. So I think I'll quickly start sharing my screen now, and we'll talk about the roadmap. And then after that, whatever time will be left, I'll again pick your questions if you have anything after looking at that roadmap. All right, so let me know once my screen is visible. Okay. Where is that? Yeah. All right, so is my screen is visible? Yes, awesome. All right, cool. So this is your data engineering roadmap. Okay, and there are lots of things. It might look bit lengthy or hectic, but don't worry, because I have covered everything. Right? If you don't miss anything from this roadmap, definitely you can crack any kind of company, even tech giants, FANG, anything. And this roadmap will definitely help you to become a good data engineer for sure, because uh, collectively we are using these things day by day in our data engineering jobs. So first thing, let me start with the programming part, right? Even somebody, the very big first question in the Q&A was, is Java important for the data engineering and other things, right? So programming, as I said, right, when and some your questions should be like, is programming or the understanding of programming really required in data engineering or not, right? So my answer is yes, very much required, because when I was saying that we need to create those scalable and optimized data pipelines, and there we will be applying some data transformation on the fly. That means you need to code something, right? How will you even apply those transformation? You need to write a code for that, for every execution, for whatever is related, right? So good understanding of the programming and the modern object oriented concepts is definitely very much important. And in the data engineering, these three languages are really popular. Any of the language, if you know and you have a good knowledge of it, right, you are like you have completed the first check. Okay, Python, Scala, Java, these three are popular, so get a good expertise in that. And if you want to take my opinion among these three, what you should actually choose, so I would definitely say Python, because even nowadays Python is being known as the language of data. Okay, and very strong support for the data analysis related libraries. Okay, and obviously easy to understand for different, even a data analyst who want to move into data engineering. Java and Scala might look bit complex because of their object oriented way of writing and executing the things, but Python bit different, easy to understand, not very complex. So you need to focus on that, their object oriented programming concepts as well, to write the clean code and simpler code, right? So programming, first thing you need to cover. Second thing is that you need to have a good idea of the operating system and the shell scripting related things as well. So operating system like Linux based system, Unix based system, and how to execute the commands on terminals, right? So any of you who have the idea about the, or coming from the computer science background, or let's say worked in the industry, so you definitely know what are the operating system, Linux based machine, Unix based machine, right? So there you should definitely know how to operate on the system, checking the files, copying the files from here and there, and automating the things, right? To automate a stuff, you need to work on the shell scripting part, right? How to write a shell script to automate some stuff, or to do some stuff in the background, right? So that's why understanding of these things is very much important. So make sure you complete this one as well. Now the third thing is that when you will be applying for the interviews, right, for the data engineering interviews, as I said, it is definitely a combination for the software engineering profiles as well. So the DSA related, data structures and algorithm related questions will be there for sure. And these kind of things you will be using in your activities as well, like building the pipeline. You might use the arrays, you might use the strings related thing or some data there, right? So you need to know the data is typical data structures things and algorithms as well to crack the data engineering roles. But the good part is that when I compare the data engineering with the software engineering, so if you even take the example of Google, let's say Facebook as well, right? For the software engineering profile, the interview round is definitely on a hard level. For if I specifically talk about the programming part, DSA and algorithm, so that level would be definitely very, very high. But this is not the case with the data engineering, because the data engineering, we just want to test this thing. So I'll explain it again in a simpler term, why this understanding of DSA is even important, right? Let's say I want to test your Python skills, whether you are good in Python or not. Okay. How can I do that? I won't be giving you a simple use case. Let's say, just write the for loop syntax in Python, right? This is not the way to judge how good you are writing the Python program or Java program or Scala program. If I want to test your programming skills, I will be giving you some problem statement, right? And I will give you the problem statement in such a way so that I can see your logical thinking ability and also your programming skills. And that's how this DSA part comes into the picture. So you need to understand how to operate on the arrays, or how to solve logical questions related to arrays, strings, linked list, stack, queues, tree, data structure, very basic level understanding. Let's say traversal related things, questions in order, pre-order, post-order. Same with graph, very basic thing, right? You need to understand the basic things about graph and its traversal, like DFS, BFS, and very basic. Dynamic programming, again, a bit important. In my 5 years of experience, wherever I have interviewed, at least in the coding question, I got one DP related question, and that too, like easy to medium level, not a very hard level of DP question. And same basic things related to searching algorithms, let's say binary search, linear search, and sorting algorithms, quick sort, merge sort, heap sort, right? So these are the basic and fundamentals in the data structures and algorithm, and you need to actually focus on that. Just a second, guys. I need to get a water. Just a second. All right. So now coming to the fourth part, right? So here you can see, right, whatever roadmap I have created, it's obviously sequential. Directly, I didn't mention anything related to big data, their tech frameworks or whatever, right? Whatever I have mentioned, it is very, very sequential and very, very crisp kind of thing, so that you are not very much confused at a one time what I need to start and how to proceed with that. Fourth thing is, which is very important, right? Even, and this is irrespective of the data engineering itself, right? Even if you are a data scientist or data analyst, right? These things are very, very much important for you. And that is like the core understanding of the DBMS, database management system, right? Even in the interviews, they will ask questions around that, and some realistic real world cases, right? They will give you some common experiences and practical, you can say, statements, and you need to think that what kind of DBMS concept can solve this problem, and what kind of DBMS concept is being used here. Okay. And even for your designing questions, right? Let's say they can give you a straightforward design question, design the database or design the data model for this and this kind of use case, right? So you need to understand all these cases. They can ask you the optimization techniques. Let's say we have this much of data in these kind of databases, and we are performing the queries on top of it. So what kind of optimizations you can do, right? So you need to know these things for sure, and very, very well. So in the core DBMS, right, basics related to the SQL, like even how to create the tables and control languages, the data manipulation related things. What are the integrity constraints in the DBMS when we create the tables? What are different types of schema, logical schema, physical schema, basic operations, what are the ACID properties, what are the transactions, what are the concurrency control in the transactions, deadlocking, indexing, hashing, what are the normalization forms, right? Different normalization form, and when to use, why to use, where to use. Similarly, what are the views, stored procedures, and entity relationship diagrams, very much important for your design related questions, right? So these were the core and very, very basics of the DBMS, and these are the fundamental building block things. You should definitely know it. Next, very much important, very, very much important, I would say must to have for everyone in the big data space. And this thing will have at least 30 to 35% of weightage in your interviews. And SQL is something which you will be using in your day-to-day activities a lot, right? For sure. Whatever complex things or analytics result you are trying to get in, uh, SQL is something which will help you. And again, I'm saying 30-35% of your interview will be oriented towards the SQL, writing the SQL queries, not the simpler and basic one, right? So in the SQL, obviously you want to crack the data analyst, data scientist, data engineering interviews, you have to be minimum to minimum 8 out of 10, right? You need to know things in the SQL till that level. So here, transitional databases like again, MySQL, Postgres, all type of joins, work with the joins, how they actually work, and nested queries, how to write those complex and nested subqueries together using the group by statement together, how to solve the problem, case when statement with the group by, and most and very, very most important is the window functions, how to use the window functions in the SQL, right? And these are the things definitely in the SQL on a higher level I have written. And why I mentioned, because mentioning topic is very much important, so that after watching this session, you can deep dive into these things and explore what is the, let's say, window functions, what all things you need to study in window functions in order to solve some of the good analytical and complex SQL queries. So that was about the SQL part. And again, I'm saying, and I am repeating myself, you need to be 8 out of 10 for the SQL part in the data engineering domain. Now from here, the things related to the big data will start. So big data here, first, I am not going to talk exactly about the, you can say, the complex things or the complex tech frameworks in the big data, but it is more about what basic things you need to first understand, right? So here you need to understand, let's say, what is big data, what are the typical technical terminologies of it, 5 V's of the big data, what is distributed computation, how it works, knowing about its fundamental complete architecture and high availability related things, what is distributed storage, how replication happens, how we create the clusters, and in cluster how data gets distributed, how replication maintained, and let's say a node get fail, then how this the fault tolerance will come into the picture, how this system makes it available again. So right, so these kind of concepts very much important to understand practically. Then what is vertical scaling, horizontal scaling, what is commodity hardware, what is cluster, different type of file formats, because in big data we will be having a very, very large volume of the data, and we need to work on some uh, efficient file formats. We need to use some efficient file formats so that we can get the good compression, we can minimize the data space, right? Because if we are not minimizing the space, then obviously we need to buy more hardware and it will add the more cost in the system. So we need to understand when to use, why to use, where to use these file formats, which is the best one, what kind of compression level they are providing to us, what is the schema evolution, right? How they are maintaining everything. So these things will be very, very much important, like CSV, JSON, Avro, Parquet, ORC. Then understanding the types of data, right? How you can deal with different types of data, let's say structured data, unstructured data, like the audio files, video files, completely text data, and then semi-structured like the JSON or XML, right? So that's why I mentioned first you need to know these basic terminologies, because when you will start with the tech frameworks, right, the exact frameworks which are being used in the big data, these words and terminologies will be used again and again. So if you're not aware about these things, you won't be getting those terms and you won't be able to catch the things. Next is the data exploration library. Since in the beginning I mentioned, and even for me as well, like till 5 years, I've mostly worked on the Python. I have worked on Java Scala as well, but my most of the work is being done in the Python. So in Python, there are two very popular data exploration libraries, right? Where you can read the data and explore it. You can apply some mathematical things, statistical related things, right? So pandas and numpy, very much important. You can even explore if you are, let's say, in the data science direction or the ML direction, you can explore few more libraries, let's say sklearn, and the you can say the matplotlib is there, right? And many others. Now talking about the eighth one, which is again very much important for your design rounds, right? Design rounds, and whenever you are working on real world use cases, because everything at the end probably coming from some source which will be having a kind of data. Probably even sometimes it can be a warehouse, like moving data from one warehouse to another warehouse, but something at source which is holding the data in some specific format and in some specific design. So we need to know the data warehousing and data modeling concepts, because it has its own specification, it has its own technical terminologies, and we need to know, right? So that we can design the efficient end-to-end complete pipelines, like including the source and then applying the business transformation, processing it, and even designing the data warehouse in the downstream system, right? Like how my transform data will be stored in such a specific table in the downstream system, how many tables I need to create, how those tables will be related with each other, their relationship with each other, right? So these kind of concepts, and I can even give you the examples. I do remember my interview questions where interviewers directly asked the questions related to it, that design a data warehouse for Flipkart. And recent, like when I made my recent switch, I do remember one of my interview where interviewer asked, in the COVID time, in India, we have the website for the vaccination slot booking, right? So can you please design a data warehouse for that? So data warehousing is, that's why very important concept. We need to know, and we need to be more realistic, and how you can be more realistic if you know these concepts, which one is used for what purpose, then you will be able to design the efficient and optimized data warehouse as well. So what is OLAP, what is OLTB, what is dimension tables, what is fact table, star schema, how to design it, its concept, snowflake schema, how to design it, warehouse designing questions, right? The practical questions I was talking about, you need to practice it so that you can crack the design rounds, right? I took few examples again. Design the Flipkart, design the vaccination slot booking center, design the VMart, right? Design the food delivery app, like designing the warehouse for the food delivery app. So these kind of questions you'll be getting for sure. Now talking about the typical big data related frameworks, which you actually need to know if you are moving into the data engineering field, right? So first I will start with the base or the fundamental or the foundation, which is important, right? Base you definitely need to know. So here what you need to do actually, first you should start with the Apache Hadoop, which is something, or the very first framework which came into the picture and was being used for the batch data processing, right? And it was the first one which was discovered for the distributed data computation. For Apache Hadoop, you don't need to worry about its complex coding, right? Because Hadoop has its own way of writing the distributed code in the form of map reduce code. But it is a bit more complex to write. You need to be, or you need to have a really good expertise in the languages like Java, Scala, then you will be able to write it, and mostly Java. But here, the things you need to focus on their distributed file storage system like HDFS, and the resource manager like Yarn, and the understanding of map reduce part, how it actually works, right? And what are its specification, what kind of challenges you can face while working on the map reduce things, because map reduce understanding will give you a clear picture of distributed computation. Okay, that's why I have mentioned understanding from the architecture perspective is very much important for Hadoop, right? Not from the coding perspective, because nowadays we have much more improved or much more efficient big data related tools which has solved some issues which were available in the Hadoop earlier, right? Next is the Apache Hive. So Apache Hive is also one of the very frequently used warehousing service in different companies. So Apache Hive is basically nothing, a kind of framework which is written on top of Hadoop, right? and it gives you a complete feel of SQL, right? You are writing SQL and it is getting executed for you, right? So let's say even if I only talk about the Hadoop, right, you need to write an aggregation. Let's say you have a historical data of 1 year, right? And you need to do some aggregation, let's say daily revenue of 1 year. You will be writing the aggregation code. If I only talk about the Hadoop, you need to write that specific code in the form of group by, in the map reduce. It will definitely take some time and everything. But you know very well, using the SQL, that can be solved even a fraction of seconds, right? Just select star or some field, comma, star, something, something, and then group by some values, right? And you are quickly done. So that's the problem actually Hive is trying to solve. Whatever you want to perform on a specific data set which is stored in the HDFS, you can write your logic in the form of SQL and you can submit it. So Hive, what it will do, it will simply what it will do, it will simply you can say just convert your code or the convert your SQL into the simple you can say map reduce code under the hood itself. So behind the scenes it is actually executing the you can say map reduce code, but for you those implementation are completely hidden. You are writing your logic in the SQL form itself, right? So that's why it is important, and again widely used by different companies for the data warehousing and analytical queries related perspective. So in Hive you need to know how to load data from different file formats, and what are internal tables, external tables, querying data, querying tables from data stores like HDFS, and what is the concept of partitioning, what is concept of bucketing, map side join, sorted merge join, how to write user defined functions in Hive, what is serialization and deserialization in Hive. So these things you definitely need to focus in Apache Hive, and very, very much important again. But nowadays, this one, right, this is something which is very, very important, and you can say a must to have skill set nowadays for the data engineers, Apache Spark. So earlier, what was happening with the Hadoop and Hive, these two frameworks are actually meant for the batch processing, batch data processing. You cannot process your data in the real time, right? As soon as you are getting the data, you cannot process it. So in order to resolve that, right, there was no new framework which was introduced, and that is Apache Spark actually. So it is actually 100 times faster than the Hadoop, and it has some really, really great capabilities. First is its runtime, because it does the computation in memory, whatever data it can put in the in memory, like in your RAM. And whenever you store anything in your in memory or RAM, you can say your execution time gets minimized, right? Your runtime will get minimized and execution will be very, very fast, right? So that's why Apache Spark is very much important, and within that there are like more than three components, but these three are something widely used. First is Spark core, right? Like writing your Spark application for the data computation, right? Performing the aggregations or any kind of thing. And let's say you are not comfortable with Spark core and you want to write everything or every logic in the form of SQL. Spark actually provides Spark SQL kind of component as well, where it will help you to write everything in the form of SQL, but under the hood, it will execute it in the distributed kind of data or distributed kind of code. Next is the Spark streaming. This component of Apache Spark will help you in order to write the real-time data pipelines and real-time streaming data pipelines. So Apache Spark is important. Apart from that, it provides the components for the machine learning as well, right? We call it like ML lib. And last is the for the graph, like whenever we have the data set where you find the graph related the where you find the graph related connections and hierarchical related connections, we have the in Apache Spark we have the like library GraphX, right? So that can be used here, and that is something very, very important. But I would say these three things, the Apache Spark core, Spark SQL, Spark streaming, you need to focus on it. Similarly, nowadays there is one more, I can probably include it here. One more framework which is getting popular, which is getting really, really popular nowadays, that is Apache Link, right? So Apache Flink is especially meant for real-time data processing, right? So real-time data processing is stream processing. It can also solve the batch processing related use cases, but batch processing will again be kind of a special case of real time, where sometimes the window timing will be increased a lot so that it looks like a batch. But uh, Apache Flink is mainly created for the real time data processing, not for the batch processing. So it is also getting very, very popular nowadays in Expedia. We are also working on the Apache Flink. We are using it for our use cases, and I'm also right now working on the real-time data streaming. We have Apache Scoop as well. This is also one of the frameworks, important one, moving data from the MySQL kind of database to HDFS, and then doing the vice versa. Apache NiFi is there. Apache Flume is also there. So these are some of the important big data frameworks you should definitely know if you are moving into data engineering. And apart from that, the two kind of things you should know: how to process the data in the batches, like the batch processing, and the second thing is how to process the data in the real time. So these two things, these two concepts and some projects for each would be a great addition in your profile. So that was the about the big data. Now coming to the workflow managers, schedulers, or orchestration tools, right? And why these are very much important? Because let's say you created the data pipelines, and data pipeline is not something which is very, again, very straightforward. Let's say you created one pipeline, read some data from source, and dump it into the downstream system. There will be sometimes use cases where you are bringing data from different data sets, and they are dependent on each other. Their time differences, their you can say like delivery time is different, right? So you need to write or you need to schedule your jobs, right, in such a way that proper dependency is maintained, like one job is running after another based on their rule, and then you are getting your desired output. And for that we need the orchestration tools or the schedulers, workflow managers. And in the market right now, these two are very popular. Apache Airflow is on the first one, and then we have the Azkaban as well, which is like important, and even I have used it. 11th is the NoSQL databases. Earlier I talked about MySQL or the transactional databases, MySQL, Postgres, but NoSQL databases is something which is again very much important. At the end, a big data related use cases cannot be solved with the transactional databases, right? Like MySQL, it is a traditional database which cannot even handle that petabyte of data scale. So obviously for that use cases we need the NoSQL databases. So the kind of things you need to know, like HBase, Cassandra, Elasticsearch, MongoDB, right? So these kind of NoSQL databases you should definitely know. Next is the messaging queue kind of framework. So when I was talking about here the real-time data processing, so it's not like that Flink uh, Flink is reading data from somewhere in the real time. Obviously, whenever we work with the stream kind of applications, the input is coming very frequently in a very fast pace. So that's why we need something in between, right? In between, as in which can hold our messages, which can hold the components, right? So that's why it is important. And Apache Kafka, very popular for the stream related processing. You should definitely know. There are others as well, RabbitMQ, okay, and so Apache Kafka, RabbitMQ, and but my recommendation is that Apache Kafka, because it is widely used. Most of the companies are using it for the stream related processing. And I just need a second because I need to plug in my charger. Just a second. So that was about the messaging queues. Now for the dashboarding tools. So dashboarding is also important one for us, but this is a kind of must to have skill set for the data analyst more. But for the data engineering is something, it is again good to know. Sometimes you need to just represent the data in order to check whether whatever we have created, it is fine or not, to test the things, right? So we need to know the few dashboarding tools as well, right? So here we have Tableau, Power BI, Grafana, Kibana, you can explore. But in the market right now, Tableau and Power BI, they are very much popular. But Grafana is something which is open source, and Kibana is something which comes with the ELK stack, Elasticsearch, Logstash, and Kibana. So you can definitely explore these one for the dashboardings. Now, last but not the least, and also I would say uh, this is something which is very much important nowadays, but as of freshers it is a bit hard as well to get the exposure of everything related to cloud. So for them this is completely fine. They can do the basic hands-on and move ahead, and you will get the good exposure related to the clouds in the companies itself. But for the experienced candidates, I would recommend, if you haven't worked on cloud, you don't have that much understanding of cloud, so please start getting it, because this thing will definitely help you to crack the good companies, and you will be shortlisted by some of the great companies because they are actually using the cloud services, right? Be it the AWS, Azure, and GCP. So here I mostly work with the AWS, and that's why I have listed down the important services which we keep on using while creating the scalable data pipelines. So if you are also starting with the AWS for the big data, make sure you are covering these kind of services for sure. And similarly, if you are using the Azure or GCP, you can explore the like same kind of services in that particular platform and get expertise on it. So in the AWS, you need to know services like EC2, which is a on-demand machine. You need a, let's say, commodity hardware on any kind of machine. You can just configure it and use it using the instance of it. Access management related, like AWS IAM, how to restrict the accesses on different services within the AWS account and how to use it. Secret managers, let's say you have some database credentials and you obviously won't be hard coding it in the code base or pushing it to somewhere. So we, in the AWS, we have a service named as secret manager, where you can store your credentials and you can access it programmatically. And then distributed file storage, S3, this is obviously a very important service to know in the AWS. And then we have the database related services. We have AWS RDS, we have AWS Athena, and we have AWS Redshift. So I won't call it as a, it is actually mentioned in the database related services, but it is more about the data warehousing service, right? So very, very widely used, right? Highly scalable and very great computing powers. And then in the AWS, we have the NoSQL database service as well, AWS DynamoDB, which is a kind of key value based NoSQL database. So this is also available. Serverless services, right, which we can use in order to create those event driven and actionable data pipelines. So AWS Lambda is there. Then we have the managed ETL service, which is AWS Glue, right, where you will be writing your distributed code in the form of Spark, right? And we have the scheduler, right, where if you want to schedule something, your triggers, you want to spin up any job. So in AWS, we have AWS CloudWatch. It supports the cron related expression. It also supports some event related expression. So both the ways you can trigger your jobs. We have distributed computation service, again, just identical to Glue. We have AWS EMR, Elastic Map Reduce. So it will be kind of a cluster. You can just choose this service, mention how many nodes you want, their configuration, and that will be available for you. And the same way you will be using the Spark cluster, it will act like that. And the messaging queues, right? We have AWS SNS, we have SQS. So AWS SQS is similar to the Apache Kafka, right? It holds the messages like in its queue, and you can read the data from it. And real-time data streaming, we have AWSkinesis. This is again something where data can come into the very fast pace in the real time and will again act like a queuing mechanism, and we can consume the data from here. So that was so that's what all I had for you guys in this session and for this roadmap. I know it took time to explain, but I know the importance of it. I had to explain everything, why, and I have included it, what is the importance of each and every skill set. So after watching this roadmap, I can bet, right, you won't be missing anything in the data engineering. This is very crisp roadmap. Again, I'm repeating, you need to follow things in sequentially as well. You can follow, but if you think at a time, you can follow things, 2 3 things in parallel, you can definitely do that. And also I will share this document with the team and you can get it over the mail. The team will flow it to you and you can even refer it in future, that what was included here. So now I'm stopping my screen and you can ask your questions. Okay. So from where should I start? Okay, I can see lots of questions.
Shashank, you
um,
may skip the questions which are, you have already answered during the presentation.
yeah, yep. Just looking. I will share that link with the team itself first. Yeah, I'll do that. Or in the chat box for data engineering with ETL tool. So ETL tool is not. See, I don't recommend you need to know the ETL tools because as a data engineer, our work is more towards the uh, kind of frameworks where you have the free hand, like the Spark. That is also something a distributed computation engine where you will be writing the code to execute and perform the ETL operation. I know we have some of the ETL tools available in the market like Informatica, Talent, but they are like a kind of complete package in itself and you don't get the free hand there, right? It is more about drag and drop. You are creating your things and everything is done for you. You cannot done that kind of optimization. So if you want to move into data engineering, my specific advice would be to work on those kind of open source frameworks which I talked about: Spark, Hive, Hadoop, Flink, right? So that would be my answer. But if you are looking forward to the data analyst related job profile, then you can specifically pick those ETL tools like Informatica and Talent. Okay, I'm good in mathematics. Which domain? I'm good in mathematics. Which domain I should look out to? You can definitely look forward to this one, mathematics. Sorry, you can look forward to the data science one. Again, I said these guys are something who are actually good in the mathematics, probability, statistics, machine learning things. But again, first try to figure out whether it excites you, whether you are liking it, enjoying it or not. If it does, then I think that would be the best path for you. Is data analyst job also good? Yes, very good. Like even folks are getting paid really well and there are a lot of things to learn. As a beginner, which course, like definitely AV analytics Vidhya, they are in this one. Like you can definitely prefer their courses.
Shashank, one of the attendees asked a question that what's the scope of data engineering in the future? Like technology is volatile every day. Like
Mhm.
automation, ML models will replace the manual skill set eventually for efficiency. So
Mm, I'm not in favor in that, right? I don't think so. That is even going to happen, right? Automation is will can be there, will or till some extent, right? Every day nowadays, technology is getting changed, right? There are new uh, frameworks coming in. There are new technologies coming in, but whenever it comes to design the scalable systems or anything, manual intervention will come into the picture, right? Your let's say automated system or any kind of fancy ML model cannot decide what kind of optimizations can be applied here or what kind of, because when you design a complete solution, right, there will be so many corner cases which you need to take care, and there will be ad hoc requirements which will come into the picture, and that cannot be solved with that kind of a specific automation tool or anything like that, right? So automation or those things can solve some generic problems, right? I'll take a very good example, these ETL tools. We have Apache Spark. You can write the whole pipeline using the Apache Spark. The thing is, you need to write a custom code there. We have the ETL frameworks like the Informatica, and that's what even I said. Informatica can help you to design those kind of pipelines, but you won't be getting that liberty to optimize that pipeline. If it is taking 5 hours of time to process, let's say 10 GB of data, it will always take it. You cannot look forward to do some optimization. Even if there are optimization, those are very, very minimal. Okay. So try to focus. That's why again, I'm again and again emphasizing on to get a good expertise on the open source kind of frameworks, because they are actually being used by the organization. Even organizations are trying to move away from some legacy tools or kind of tools where they need to pay the license fee, something like that. And that's how you can grow. And don't worry about the future. Data is the future. In last 10 years, we have seen how much boom we have seen in the big data related job profiles, be it the data science, analytics related profiles, their compensations, their needs. Right now, job market is very, very hot, right? Every single company is working in the big data space. For even simpler use cases, they are hiring for the big data related profiles. So that would be my answer. Future is really, really bright. You don't need to worry about that. uh is big data outdated? No, it's just started. How it can be outdated? Which cloud course for the beginner do you suggest? Online cloud, I would definitely say you can just check the analytics with Vidhya for sure, right? They have everything. They even I in my days I followed analytics with Vidhya for the big data related things to understand, right? And they have the cloud related stuff. They are actually making good people and helping the folks who want to move into the big data space. You can definitely check. But if you are specifically looking for some certifications, even AWS has its own certifications for different levels. You can explore their site and you can crack those certifications exams for the big data, for the cloud. In advanced knowledge of Docker, Kubernetes. Yes, Mayank, this is something which is important. And even in the beginning, if you remember, we are using the best practices, right? Even right now in my company, the solution we are working, it is completely a containerized Flink application we have built, very scalable, right? In the microservice architecture, we use Docker. And now we are moving into the Kubernetes as well, right? For the deployments and to move the things there. We have the CI/CD tools, Jenkins, and everything. So best practices will always be there if you are working in the good companies.
So I think most of the question here now are repetitive, or they can be answered, can be the solution can be found out easily. I think, and yes, you can check out our analytics with the platform. You will find most of the resources to kickstart your journey in this data science domain. So please go out, check our blogs or free certifications. You'll definitely find it useful. So thank you, Shashank, for a wonderful session. I think today's session was definitely very helpful for the beginners who want to kickstart their journey in the data engineering domain, and also for the people who want to switch their career in this data science domain. So this session ends here. Thank you all attendees.